The cars are crashing together. The heavier car has a velocity of 20 meters per second, and the mass is 2,000 kilograms. The second car, car B, let's call it, is at rest with a velocity of 0 with half the mass. The mass is 1,000 kilograms. Given that the cars stick together, this makes it an inelastic collision. When the cars stick, we need to find the final speed, call that VF. So we use the equation for conservation of momentum in inelastic collision. The total initial momentum, or the sum of the initial momentums, equals the sum of the final momentums. So the momentum of car 1 is 0. Remember, momentum is mass times velocity. So we could show that the mass of car A and car B, the mass of car A times the initial velocity of car A plus the mass of car B times the initial velocity of car B, which is 0, equals the mass of car A times the final velocity of car A plus the mass of car B times the final velocity of car B. Since these cars stick together, VF is the same, right? It should make sense that when they're traveling together, they should have the same final velocity. So car B has an initial momentum of 0, so we don't need to write that. So we have the initial momentum coming completely from car A equals, and here we'll common factor out the final velocity, because it's the same number in each car, A and B. And when we do that, we have the sum of the masses in parentheses. Isolating for VF, which is what we're trying to solve for, we have this divided by the total masses. And now we can plug into this to solve. So we have mass A is 2,000 kilograms times its initial velocity is 20 meters per second divided by the sum of the masses. So we have 2,000 plus 1,000 kilograms is 3,000 kilograms. This will evaluate to 13.3 meters per second. So it should make sense that the final velocity is a bit slower, given that the initial velocity of car B is 0 and it's being hit with 20 meters per second. These cars should both be traveling slower than that after the collision. And so you could see it was reduced by less than half the initial speed.